Hello everyone. Today we are going to learn about Micro Electro Mechanical System, commonly known as MEMS. MEMS technology used in many devices that we use every day such as smartphones, cameras, cars and medical instruments. In this lecture, we will understand what MEMS are, their components, how MEMS are fabricated, how they work and where they are used. MEMS are very small systems that combine electronics, mechanical parts, sensors, actuators. All these components are built on a single substrate, usually silicon, using microfabrication techniques such as deposition, patterning, and etching. Because MEMS are very small, many functions can be integrated into one tiny chips. In this lecture, we will cover what MEMS are, main components of MEMS, fabrication process and methods, MEMS operation, application, and short summary at the end. MEMS devices typically have sizes ranging from 1 to 100 micrometer, which is much smaller than a grain of sand. They include miniaturized mechanical structure, sensors that detect changes, actuators that produce motion, and microelectronics for control. An important feature of MEMS is that at least one part has a mechanical function, whether it moves or not. MEMS consists of four main components. First, microelectronics, which act as brain of a system. Second, microsensor, which collect data from the environment such as pressure, temperature, motion. Third, microactuators, which convert electrical signal into physical action. Fourth, microstructures, which are very small mechanical part built into a silicon chips. And then MEMS fabrication process. To build MEMS devices, special fabrication processes are used. The three main processes are deposition, patterning, etching. Deposition process. In deposition, a thin layer of material is placed onto substrate. This layer can be only a few nanometers thick or up to several micrometers. There are two main types, physical deposition and chemical deposition. Common materials include silicon, metals, oxide, and polymers. Patterning process. Patterning is the process of transferring a design or pattern onto a deposited material. This is usually done using photolithography. Patterning defines the exact shape, location, main structures before etching. Etching process. Etching removes unwanted material to create structures. There are two types. One is wet etching, dry etching. The choice of etching method depends on shape, depth, accuracy, safety, and cost. Next one is fabrication method. Bulk micromachining is the oldest MEMS fabrication method. In this method, parts of silicon substrate are selectively removed to create mechanical structure. Wet chemical etching is commonly used because it is fast and selective. Etching can be isotropic and anisotropic. Surface micromachining. In surface micromachining, thin layers are deposited on the surface of a substrate. A sacrificial layer is first added, followed by the structural layer. After patterning, the sacrificial layer is removed, allowing the structure to move. This method allows higher integration density, low cost per device. However, material properties can sometimes be difficult to control. Wafer bonding. Wafer bonding involves joining two or more wafers together. There are three types: direct bonding, analytic bonding, intermediate layer bonding. In this method is useful for creating complex MEMS structures, but wafers must be very clean, and flat. High aspect ratio fabrication uses a technique called deep reactive ion etching. It allows very deep etching, nearly vertical sidewalls, structures hundreds of micrometers deep. This technique is very important for advanced MEMS devices. And then benefits and the trade-offs. MEMS devices offers many advantages. They are very small in size, low cost, low power consuming, fast in response. However, designing and fabricating MEMS at small scales is challenging, requires precision. MEMS technology is found many everyday devices such as you can see already smartphones, tablets, cameras, gaming devices. Most common modern electronics contains at least one MEMS sensor. MEMS sensors and actuators. MEMS sensor and actuators are use different transduction method. The main types are capacitive, piezoelectric, thermal. MEMS can be used in microfluidic system for controlling tiny amount of fluids. Next one is MEMS operation. Two very Two very important MEMS devices are MEMS accelerometers, MEMS gyroscope. They are used to detect motion, tilt, and rotation. These sensors are widely used in mobile phones, vehicle, and navigation system. Biomedical applications. MEMS play a major role in the biomedical field. Examples include blood pressure sensor, implantable pressure sensor, glucose monitoring devices, drug delivery system, MEMS surgical tools. Some MEMS sensors are as small as the head of a pin.